Little introduction about myself. So I'm Beau Cameron. I am a practice lead at Turn Digital. We are a managed services and consulting company. I'm a Microsoft MVP for M365 and M365 development. I am on the PnP team as well. I help maintain PnP.js, which is a client-side library for working with SharePoint APIs and Graph APIs. So today, I want to kind of talk about building an add-in for Office that utilizes OpenAI. I feel like add-ins don't get enough love, but they have a ton of functionality that can really improve the user experience. So I'm gonna have a very, very brief overview of how add-ins work. I'll show some high-level architecture of what I built. We'll do some demo and then a bunch of code. This is a pro code solution here. And someone commented PnP.js rocks. It does. Oh, that was Mark. It does. So what was the reason for building this? Well, if you've used Copilot yourself in Word or unfortunately PowerPoint, you know it can be quite buggy. It doesn't work super well, and you don't have a lot of control over what it can do. And the current functionality that it has is actually really limited. Even with the MPC or MCP servers that Microsoft just released at Ignite, they don't have a ton of functionality. And so I also wanted to provide a pro code demo that shows an architecture or design pattern that I really like, specifically for AI solutions. And then recently, Microsoft has released the ability to build an add-in of just function commands. So you could have a JavaScript file in an add-in that you could then associate to a declarative agent out of the box, but it doesn't work. But I will do a future demo of this in the future because I really think that it's a really cool feature to extend Copilot with your own custom functionality within Office. All right, so how do add-ins work? Well, they are basically a manifest, a XML file, or if you're in a unified manifest, then it's a JSON file that defines the add-ins features and an application that it's going to run. And that application is some web application, JavaScript app that you host yourself that has all of your code, and it renders it within the Office application. Okay, so it includes things like the add-in name, how it looks and renders within Office, the URL that the application is going to run from. And there's different ways you can build add-ins. So the first is you can kind of instantiate it from a custom button within the toolbar itself, and you can add it to different tabs within Office if you wanted to add a button for quick access to one of your add-ins or to execute code as well. You can also, if you're in Excel or PowerPoint, you can build objects within the documents themselves. So you might want to build your own custom graphing control that you would want to pull content from an Excel file and then render it within Excel. That's completely something you can do within a Office add-in. And then what you'll see most of the time is a combination of the command bar and a task pane. And a task pane is really just a hosted iframe of your application itself. The add-in will inject some context about the document you are in, and then provide you some rich capabilities, a API of which you can interact with. And so this is kind of the standard way you will see a add-in represented within Office. For example, if you're using Copilot today, and there's the chat experience on the right, that is the same thing. Now, what's important is this all only works really when you implement the context with Office.js. So Office.js is a SDK or an API for the different Office applications. So when you run an add-in, you will get context and a SDK to interact with either the Word document, PowerPoint document, Excel document. And it's a very rich API. It has a ton of functionality in it that allows developers to access things like the selected text, the whole document, to parse through a document. So you might have a 50-page doc and you want to run through every single page and grab the content from it. The API within Office.js allows you to do so. There's also a pretty strong events API. So when a document is loaded, or if you're in the document and you're making changes, for example, there's a on paragraph added event. So if you're working on a doc by yourself or with others, these events you can attach onto with your own code and then handle the callbacks for it. So you can see that code on the right-hand side. You basically say, with Office.js, word.run, and then you're going to get the context of the document. There's an on paragraph changed event, and I'm going to add my own handle change event. So when someone makes a change, I can see what that change was, what the old value of the text was, or the event, and the new, and then process that accordingly. This slide, we can send those links, or David will in the chat, to all the documentation for Office.js. So what I built is kind of two applications. One is the client-side applications. It's an Office add-in for Word, and it's going to make a call through a Node.js API. The reason that the API exists there is that we have API keys for Azure OpenAI that we don't want exposed as part of the add-in, right? So I have a very small Express API that has one route, and it's just a wrapper for Azure OpenAI, and I will be using the chat completions API. So how it works is if you're unfamiliar with AI, you send a prompt in, and you might ask it something like, summarize text. That is something that AI can do by itself, and it doesn't need extra functionality added in. But there may be scenarios where you need to extend the functionality of the LLM, and that's where tools come in. And you create these tools, which are custom functions that can operate and do things for AI when it needs it. So an example might be, get the weather, which is unrelated to my demo, but it's a common thing you might see in tutorials online. LLMs have no idea what the weather is. And so what you can do is build a tool that calls some API. And so when you send the prompt in, the LLM says, hey, they just asked for what's the weather in Denver. I have no idea, but I see a tool attached to it that allows me to get the weather. And so it responds back on the response from the prompt saying, hey, in these tool calls, I'm looking for a specific tool and I want you to call it. So in the Office add-in that I built, what I'm going to do is I'm going to have a ton of different tools, a tool to add comments, a tool to format text, insert text, highlight text. And these are all tools or functions that are going to interact with the Office.js API. So we'll send a call in like, hey, summarize this document. It will then come back on the response and say, hey, I'm looking for a tool called Summarize Document. Do you have it in your registry? It will locate it. It will execute the code, and then it will respond back with it. All right, so high level there. So what we're going to build, or what I did build, is we're going to have an Office add-in for Word. We'll use the task pane on the right-hand side. It's a very simple experience. It's going to be one search box, but you're going to see some interactions between the chat experience, interacting with the document, but also interacting directly within the chat feed on the right-hand side as well. So let's just do a quick demo. And I'll bring up my Word document, and I'm just going to reload my add-in here. All right, so one thing that I'll just start off with is I might say, generate me a short story about a dog named Vesa. And this is something that you would see in any type of chat GPT experience. Is going to take the prompt, send it off to OpenAI, and then hopefully respond with a response. And it did. It responded directly into the chat here. So we have Vessa's big adventure. But what if I actually wanted that in the document? Well, my chat experience and the LLM has no idea how to interact with the document itself. So we need to build a bunch of tools to allow me to do that. So I might say instead, add a short story about a dog named Vessa. And the key here is I'm saying add a story. Okay, which is a little bit different than write me a story. Okay, so add might imply to the LLM, hey, I need a tool here to actually add it to the Word document. And that's what we actually have. So it actually just did add a short story about Vessa, the dog, to the Word document. Okay, I'm going to reload my add-in as well just to get rid of some context here. But now I have a short story about a dog. I may ask it similar questions like, what is the dog's name? Right. I grab a document and I want to learn about the document itself. Well, now I can ask it a question. It can grab the context from the document, so pull all the text, or I could even do selected text from the document. It will send it off as context to the LLM, and then it will respond back, and we can see that the dog's name is Vessa, right? Or I could do things like write a brief summary of the story, which is a similar thing, right? It's going to grab the context that it needs from the document on the left, send that off to the LLM, and then respond back that this story centers around Vessa, a golden retriever. But we can now do actual cool things using Office.js and really interact with the document a bit more. I might say, highlight the dog's name, and it has highlighted the dog's name, Vessa, in the document on the left. And that is because I built a tool that can highlight this dog's name. So I want to look at this code first to show you how we set this up. So I mentioned before that a add-in is a manifest and a web application. So we have the manifest here. It defines the application itself, what hosts your code is going to run from, its permissions, how it loads within the Office app as well. Is it in a certain tab? What do the buttons look like? So when you look in Word here, and you go to the Home tab and you go to add-ins, that is what you see here, the actual icon and the name. Then I have kind of two applications here. One is the back end. This is our middleware, and I can zoom in a bit more. And it just has one single route here. I'm just doing a chat route, and all that does is that's going to call chat completions, and it's going to pass over some messages that I'm going to send to it and then respond back, right? So this just exists to hide my API key. Then we have the actual front-end application, the add-in that you visibly see within the UI. And that's very simple. It's a simple chat screen. It's an HTML file, and then all of my code gets bundled in and added as a script tag, but it's just a window for the output, and then I have that input text field that you saw right here, right? Very simple. Then we have the chat file itself, and this is what actually does all of the orchestration between sending a message from the add-in itself through the LLM and then back. And so I want to walk through some of these things. So I set up my backend API, and there's some configuration there, which is like the endpoint itself, which is my local host for the API. I have a context resolver, and this is really this determines what context gets sent to the LLM itself, and it's quite simple. All it does is it either looks at the full document and passes it over in the call, or if I selected text, it would just pass over what I've selected. And so I use Office.js to determine, am I selecting text, or am I going to pass the full context. Then we have tools, and I'll talk about that after. But how this works is we'll send some message from the input when I hit enter or submit. Then I have a prompt for my LLM. And so you don't need all of this stuff here, but basically it tells the OpenAI that you are an AI assistant for Word. You have access to some tools, and then I did some prompt engineering here to help it determine which tools it might use. But you technically don't need these things. This just helps aid it in deciding which tools it should use. Okay, so it makes calls, then it gets responses back, and if there is a tool that it needs, it will come back on the tools call object. And what we do is we kind of attach tools, and if we find a tool, then we execute that code. And so I want to talk about the design and architecture of something called the strategy pattern, which is a behavioral design that allows you to define kind of your own family of algorithms to encapsulate their functionality in their own independent separate class that you can interchange at any time, whether at runtime or ahead of time. And I really like this approach because it encapsulates all the functionalities of tools so that you can add and remove tools as a dev without ever touching the underlying orchestration of those tool calls. So it kind of separates concerns here. How it works is I create a base interface for a tool that has a simple execute function, which is just abstracting out an underlying abstract method called execute implementation. And every custom tool that I build is going to implement this execute implementation method. Here's a sample of a tool. So we might have a summarized document tool that inherits from our tool, and it takes a title of the tool, so summarized document, the description, and these two are very important in how they are named, because these are what tell the LLM what the tool is and whether it should be called. So if you have a tool that has a bad name and a bad description, the LLM is not going to find it correctly. The next is we have input properties for what that tool is expecting. So in summarized document, I might have the analysis type. I might summarize it for the theme, a summary, or key points, right? And this is important because the LLM will look at this as the schema and say, oh, this person's asking me to summarize a document, and it's expecting this as input, and the LLM knows how to actually transform that input for you. And then we actually have the implementation of what this tool does. Then we have a registry for our tools, which basically allows me to add my tools as well as get the tools when I execute them. And when we want to add our tools, we just take the registry and we add our new tool class. Okay. And so what that looks like is I make a call to AI. I pass in all of the tools I've registered. The responses that come back come on the tool calls object. I then just loop through each tool it's looking for. And my registry has the registry of tools, and it just execute them with the name of the tool, the arguments, and then whatever context I want to provide that tool. And in this case, it's either the text itself or the full document. Okay, so in my solution, I have a ton of different tools, and I have tools to apply themes. I have tools to add comments, insert text, parse documents, track changes, all of these different tools that I've built. You can see that they have the name, description, the properties that it's expecting, and then the core functionality. For example, if I asked it to bold some text, it would find the format tool is on the registry, and then I can run my Office.js code inside to do whatever I asked it to do. So when the format text tool runs, it's going to say, oh, an argument came in saying bold the text. So it's going to take the range, which is the current text I've selected, and then it's going to apply a format on top of it to make it bold, right? So we build all of these different tools to interact with the Word doc. We saw this tool in my demo where I said highlight text. So I said highlight the dog's name. When it came in to run this tool, the arguments passed in Vesa. And so I'm going to use the Office.js search API to search the entire document for all instances of the word Vesa. I'm going to apply some color that I want to highlight it, and then it will apply the color for every time it finds that word. Now, I did not use in my demo what color I wanted, but I could have said highlight the dog's name blue, and you'll see that it highlights it blue. So what happened is it came into the execute method of our tool, and it said, oh, it was looking for either an argument of the color that was passed in or defaulted yellow. So I said, make it blue. So it actually used the blue color to highlight that text, right? So we can build all these tools. We add them at runtime, and then the LLM knows when to call them. But let's ramp it up because these are kind of lame demos. So some things we could do. Let's say that I am reviewing, or someone has reviewed my story here. So someone adds a comment here and says, this is bad. The dog's name is actually Hugo. Please fix this. And they might maybe say, they select this whole text and say, this sentence structure is bad tone and awful. Be ashamed. Fix it, please. They said please because they're being nice, right? So I open up this document and I see that there are comments here. Well, I can use Office.js and our tools to work with these comments using AI. So I might come in and say, what is the overall tone and feedback of the comments? And I have a tool that will, when it gets called, will loop through all of the comments in the document, review the text within them, then send them off to the LLM, and then provide some feedback. So it says the overall tone is negative and critical, and it let me know that someone said it was awful and I should be ashamed. And then it gave me a summary of what that is as well. So that's super cool, right? I can build my own tools to interact with the comments in the document. But I'm lazy, and so I actually don't want to actually fix all of these things myself. Well, that's easy too, because I can just build the tool that loops through the comments, reviews what they say, and then interact with the Word document at real time. And so this is going to be something that I call a workflow. It's going to be a tool that incorporates maybe other tools like replace text and some AI functionality. So I would say something like read any comments and make requested changes. And there we go. So it said, oh, the dog's name is Hugo. So it changed every instant of it in the document. It let me know that it changed it, as well as it rephrased the last sentence. And you can see if I do Control Z here, it changed it from "and so Hugo whiskers blah blah blah" to a new sentence, and then let me know that it made that change. So that's super cool, and that's what I call a workflow or a complex tool. And this tool is much larger. It's not a simple implementation. It's going to get all the comments first. It's going to loop through every single one. It's going to grab the text of the comment. It's going to see, is that comment referencing highlighted text in the document that it's referencing, or is it the whole document? Then it's going to send that off to AI. And you can see here is what it's asking it to do. The has range is, was it selected text? It says you are a document assistant. When a comment is attached, blah, 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 do all of these things. It gets a response back, and then it needs the tools. Well, we have a bunch of tools that we've registered. And so it can use any of the existing tools that I've built. So it might, on the callback, when it's looking for replace the name, it will find the replace text tool. And so it's going to go search for Vesa and rename it to Hugo. So that's really cool, I think. But it's to me not agentic enough, and agents are the new thing. And this is where the events API comes into play. So there's a lot of events you can use that I talked about before. I'm going to use the paragraph added event. And I built a tool called Co-Editor. And I'm just going to say enable Co-Editor. And all that's going to do is, if I go to that tool and go to the implementation, I am going to start the editor itself. That is going to go to a event controller that I built that allows me to add and remove events. But underneath it, it's just going to say, hey, add the paragraph complete or complete event. And in there, it's going to register the Office.js event for paragraph changed, and then it's going to add the method I passed in. So when a paragraph does change, I have my own handler for the callback, where I can then say, hey, when something does change, run a new prompt, and let's analyze for conciseness, feedback, be honest, and then provide that in a comment back to me. So let's just go in here and write something completely false, like the piano is a 6-stringed instrument that lets you play music with your feet. And we know this is completely inaccurate, right? But I hit enter, Office.js is going to fire off an event, and it sent the text to the LLM. The LLM read this and said, this is wrong. It's not a 6-stringed instrument, and it's not played with your feet, it's with your hands. And so that's super cool. As I start to type more, like Hugo didn't like the way I referenced him in the story as a dog. And I can continue to type and evolve, and the LLM is just going to continuously edit with me as I'm writing out this document. And I can fine tune how this tool works, right? But this says, hey, you might want to rephrase this in a different way for conciseness, clarity, so on, so forth. So anyways, that's my demo. Wanted to show how you can build your own extensibility into Office and how you can use Office.js to build really rich experiences for your users.